Hello, dear students. I am Dr. Kapil Chaturvedi, Associate Professor in Department of Computer Science and Engineering, Sage Group Bhopal. In this lecture, we will discuss our software engineering's topic, project measurement. Basically, that project measurement is much important from the project maintenance point of view. Many of the terms which we will discuss in this topic uh, will be important from the examination point of view as well, the practical scenarios point of view. Like software configuration management. If someone asks to you, what is software configuration management? So we know very well that what is software configuration. What if I am asking about what is software configuration management, then that question is some kind critical because I have to mention some heads at the time of examination. But the answer is also silly. As the staffs of the SDLC, you can see that in SDLC staff, so we in general discuss recognition of need, feasibility study, analysis, design, implementation, post implementation. So these are the staffs of SDLC in very similar manner. If you are discussing about software configuration management, you will have to first of all plan what kind of configuration we require. And then whatever the scenario, what is the environment of the organization, what kind of software we have to deploy at the client site. Thereafter, we have to analyze and design the actual framework to deploy what kind of hardware we require to deploy the particular kind of software on the client side. Like what will be the configuration of the systems where that software will use, what kind of configuration we require at the server side, or how much the users will use that application at the same time. So, and what kind of networking, what kind of bandwidth we require to use that application, how much loaded your application on a particular time. So that kind of analysis you have to make and make a proper framework and design to implement network and relative hardware and software configurations scenario in diagrammatical way. Thereafter, you have to actually implement that configuration. Then, by deploying that hardware and software, you'll have to test whether that configuration you configured uh, is working properly or not. Thereafter, you release that configuration and deploy the application on that hardware uh, and that over that software, over that platform, and the maintenance go on uh, continuously. Next terminology is software change management. So that is a periodic process in the whole software maintenance phase, where customer ask for a new change, where customer say to you, you'll have to, it require a new module, you want to add a new module in existing software, or you want to provide, you want to require any new functionality in the software. So what kind of phases we'll have to face? What kind of procedure you should adopt to make that kind of changes? So first of all, you will have to request for change. So customer will make the request for the change. Now we'll have to analyze what will be the impact of that change over our existing system. There, after approving or deny, you'll have to decide that whether you'll have to select, you'll have to go further to implement, make that kind of changes, or you'll have to deny. If you are feeling that, if you are realizing that that kind of make changes, if we make that kind of changes that can affect the whole system, so you will deny that changes. And if you are feeling that that kind of changes is possible in existing system, that will not affect to the software. So we will approve that and go for implement that requirement. And after reviewing, we'll report to the customer and add that changes or make that changes in existing system. So this is the cycle of change management. Another is software engineering, software project management, that's SPM. So what is actually is SPM? Software project management is what is software project management actually? So that is a procedure, four-step procedure: planning, execution, monitoring, and control. Once you deploy the software on the client side, continuous maintenance will go on, and the management phase is also go on. Also, during the development of the software, maintenance management phase is continuously control the software. What is the status of the software? What is the quality of the software? What kind of customization we are providing? Uh, Whether we are going to fulfill the requirement of the customer or not. So that kind of controlling, monitoring, uh, continuously go on, parallelly go on during the development of the software. So planning, execution, monitoring, and control phases say that planning, it means you'll have to plan how you will manage the software. Execution, it means you'll have to apply, continuously execute the management procedure. Monitoring, it means you'll have to monitor the schedule, customization process, uh, codings, errors, logics, whether that is implementing properly or not. And controlling is a phase where you'll have to respond to the developers. If you are feeling that is there any issue in the software development, then you can directly contact the developer and control the current situation, current scenario, or current working procedure. Version control is the most important part of the software. When you deploy software on the client side, the continuous updation will go on. And when you make major changes in the software, new version will be released. But the issue is that whenever you make a new change or new major change in the existing software, the problem is that what about the previous or existing system? Or if you are making multiple versions of the software. So after some time, you will confuse what is the recent version of the software. So what you will have to do, you will have to make a copy of the existing software because you cannot stop running software, running application, running website like Amazon. You can never be stop the Amazon for the 2 days, for 2 hours uh, for the updation. You will have to make a copy of the existing running software and make change appropriate changes and update and commit that appropriate changes in centralized version on the over the server with a new version name. So that functioning, that mechanism is continuously go on. You'll have to always be update the centralized version instead of keeping that version in different places. And to identify that, you'll have to give a proper version name of that. Now, in the last lecture, we also we already discussed the engineering and reverse engineering fundamental. But if you are going to implement a actual reverse engineering procedure, then you'll have to follow that cycle. Now, as we know that the formal definition of the reverse engineering says that re-engineering is the reorganizing and modifying existing software system to make them more maintainable. So, as we know very well that we apply re-engineering and maintenance phase, but how we'll apply? So you will have to see that cycle. So what you will have to first do? Inventory analysis. It means existing system. You'll have to analyze the existing system. Document the reconstruction because you are going to make reverse engineering. If you are feeling some changes, then you will make the changes and update the documentation. Reverse engineering, you'll have to actually apply the reverse engineering code reconstruction. Then data reconstruction. Sometimes you have to make some changes in the data. Forward engineering, it means once you perform the reverse engineering, you have to go for the forward engineering to check whether we make or find the facts in reverse engineering are correct or not. So check that. So to check that, you'll have to apply the forward engineering. Another diagram to explain you reverse engineering uh, is here. So the software reverse engineering is a process of recovering the design, requirement, specification, and functions of a product from an analysis of its code. It builds a program database and generates information from this. So there is one of the mechanism, example mechanism. This explains you the reverse engineering mechanism, refine data extraction, and in the extraction phase, we are following three phases: database, interface, and processing. Because extraction is not a simple term. Extraction is a typical procedure where we are fetching the data from the database. So to interact the data from the database, we'll have to make interact by a front end code. You'll have to need an interface to fetch that data from the database, and by approving that, by checking the credentials, you can process the data and fetch the data and use in application, refine and simplify, and final specification. So that is the one of the example of reverse engineering. Now the feasibility analysis, as we discussed in the SDLC. After the recognition of need, we go on feasibility study. And I told you many times, feasibility is not just to check whether uh, that application is possible to implement or not. Feasibility study is a major part of conception of one of the project, because here we make a feasibility report and client will approve that feasibility report uh, to check uh, many of the things, like what kind of front end tools, what kind of back end tools you are adopting, what kind of third party tools you are adopting, what will be the schedule you decide to implement the software, what will be the modules, how much team size will work on over the project. So many of the things we mention in feasibility report. And there are some types of feasibility, like economic feasibility, where the financial concern will discuss. Technical feasibility, where software and hardware requirement as well as third party software and technical requirements will be mentioned. Operational feasibility, where functional and non-functional requirements will be mentioned shortly in the form of modules and major functionalities in the feasibility report. And schedule feasibility, where again chart or the schedule will be given to implement the software, how much time that particular software will take to develop, and bifurcation will be there to complete each and every phase. How much time will take analysis, how much time take by the design phase, and how much time you require for the coding phase, and on what time you will deploy that software on the client side. So the different kind of feasibility here we are mentioned, and the combination of these different kind of feasibility reports will be known as feasibility final report, which will be approved by the client before starting the project. There are the example of a project schedule, uh, as we discussed many times, the Gantt chart uh, to schedule our software, how much time we will take to complete our requirement specification and analysis, how much time we will take and to complete the design. So here we are mentioned some months, and here we are mentioning some duration of that, how much time we will take. And here we can easily say that in the end of the April, we will launch the software and deploy on the client side. So that software will take about 4 months to complete. We can easily say by just seeing that software. That chart is the project schedule chart, which is also an important part of the feasibility report. Project tracking is the major part of the software project management. Whole procedure says that uh, there are many of the concern during the software management, like budget. uh, customization, quality, security, how much manpower we require, how much budget we require. So to control and monitor these all things in today's era, in today's life, practically many of the automated tools are available which continuously monitor the application developers work and the project status and generate the report, different kind of report, so that you can easily understand and track what is the actual status, recent status of the software. Here you can see that here a list of the tasks and assigned to who will develop, who will work on that particular task, and what is the priority of that. So as we can see that here star marks, it means the priority of this particular work is high. What that particular work's priority is not too high, and here are the status: complete, 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 overdue, in progress, not started. So that kind of representations will be generated by the automated softwares over the project management process, so that you can easily track the status of the software easily. Uh, Software quality assurance is also known as SQA, or in many of the industries, the term is known as quality assurance or QA department. That department is much important in pharmaceutical companies, where uh, before releasing the medicine on the market, in the market, quality assurance department ensures that that application, so that a particular medicine should be uh, go for the transport or not. In similar manner, in software industry, before deploying the software, some on the by the basis of the some of the factors, software quality assurance team will check that that software should deploy on the client side or not. That basically software quality assurance is a part of testing mechanism. So that SQA is the last procedure of the testing mechanism, so that a tester team can decide, yeah, whether that application should be deployed or not on the client side. So here some of the phases, like user experience testing, functionality testing, performance testing, compatibility testing, test management, and security testing. So that kind of test majorly adopt during the software quality assurance procedure, so that uh, we finally decide that that software is complete from the quality's point of view, and now we can deploy that software for the end users use. Now, for our project planning matrix, as we know that the planning matrix is a tabular format in the software engineering's language. We always term use matrix for the table. So here we are project planning matrix. We are mentioning, also known as PPM. Here some of the had we are taking: narrative, summary, objective verifiable indicators, means of verification, assumption, and risk. So we are going to plan something. So we have to make some, we have to decide some heads like goal, purpose, output, and activity. What is the goal of our project? What is the purpose of developing the software? What will be the output by developing that software, by using that software? And activities, what kind of activities we have to perform? What kind of activities performed by that application, by using that application? What are the actual application areas of that? Here we are mentioned some objective, means, and verification and assumption. And, we achieve the goal. What will be the risk, and what will be the uh, uh, our gain after completing that goal, after achieving that goal. So basically, this is the idea. I'm not saying to you that you'll have to keep in mind these all things in mind. I just want to show you that project planning matrix that can be in your own way. You can implement your own project planning matrix, but there are some there should be some heads on which you make some uh, matrix. by on the basis of some heads like goal, purpose, output, activities. Each and everything is very clear. So basically, in most of the cases in project planning matrix, these heads will be used because each and every software have some goal. Each and every software have some purpose to develop, and each and every software will generate some output, and some of the activities, many of the activities uh, will be the part of that particular software. Now, the cost estimation is another important concern in the software because none of the software implemented uh, freely, as we can see easily. We never any of the no one will create, no one perform their effort, no one best or waste on the time to develop the software which has no cost. And if you're going to implement some of the application, you must know what are the major concern, what are the major factors to estimate the cost of the project. So size estimation is the major criteria to calculate the cost. But to calculate the size of the project, we'll have to go majorly go on two fields, two sides: effort estimation and duration estimation. Effort, it means how much manpower you require, how much uh, infrastructure you require, how much effort you apply to develop that software, in the sense of manpower, in the sense of hardware, software, and many more things, supporting things which you have to which you require to develop a software. And duration is also another concern, where you have to check that how much time we spend to develop the software. Because without calculating that, you cannot decide that what is the actual cost of that software, because you are the software company continuously paying the software developers. So in the absence of duration of the estimation, you cannot calculate the cost of the software. And to duration estimation, you make a schedule for effort estimation and duration estimation, stuffing estimation you require to make. But basically, we are performing whole things, whole activities majorly to calculate the cost of the software. So this is the PPT in which we cover many of the things related to the software management and software measurement. So this is the some important questions, some important topics from the fifth unit of software engineering. If anyone has any query, then directly ping me on kapil.rgtu@gmail.com. Thank you.